Imagine discovering a fully formed human skeleton that dates back millions of years before our own species even existed. Astronomers have found this exact paradox in the deep cosmos, a supermassive black hole that appears to be older than the galaxy surrounding it. This object possesses the mass of billions of suns. It was already fully formed when the universe was less than 700 million years old. The order is backwards. Cause follows effect. This broken timeline suggests that the physics governing the early universe operated differently than any model we have constructed. The established chronological order of the cosmos is straightforward. First, the Big Bang, then cooling gas, then the first stars. Eventually, those stars clustered to form galaxies. In this model, the galaxy acts as a cradle. It exists first, providing gas and stars to feed a growing black hole. The new data reverses this sequence, placing the fully formed black hole at the very beginning, before the host galaxy gathers mass. If the cosmic child birthed its own cradle, then the mechanisms that first triggered the formation of our universe remain unidentified. The machine responsible for this discovery is the James Webb Space Telescope. It's an instrument designed specifically to look backward into the history of light. Its launch represented a global effort to observe the earliest era of the universe, a period known as cosmic dawn. Because light takes time to travel, looking into deep space is a form of archaeology. We are seeing the universe as it looked billions of years ago, captured as fossilized light. Scientists expected Webb to find a chaotic nursery, small, primitive clusters of infant galaxies just beginning to take shape. Instead, the ancient light revealed mature cosmic giants. The universe reached a state of high complexity far earlier than our theories allowed. The data shows these supermassive objects existing when the universe was in its absolute infancy, less than 700 million years old. Normally, a black hole grows through a slow process of accretion, consuming gas and stars over billions of years to reach a massive scale. But these objects already hold the mass of billions of suns. This growth is governed by the Eddington limit. If a black hole feeds too quickly, the resulting radiation pressure pushes matter away, starving the hole and setting a strict speed limit on its growth. Even at the maximum feeding speed allowed by physics, there simply wasn't enough time for these objects to grow this large. The math of the early universe is currently irreconcilable. To resolve this contradiction, astrophysicists are examining radical hypotheses that move beyond standard evolutionary models. One theory is direct collapse. It suggests that massive clouds of primordial gas might bypass the star formation stage entirely, collapsing inward to form a giant black hole instantly. Another possibility is that the young universe allowed black holes to temporarily ignore the Eddington limit, gorging on matter at speeds that are impossible in the modern cosmos. This leads to a third, more significant possibility: primordial black holes. These objects would be born not from stars, but from the Big Bang itself, emerging from quantum fluctuations just milliseconds after the beginning of time. If these primordial seeds are real, they predated stars and galaxies, acting as the gravitational anchors around which the first structures of the universe assembled. The telescope is functioning perfectly, the data is consistent, and the measurements of these impossible objects have been verified. In the scientific method, when a physical observation contradicts a long-standing theory, the observation is what defines reality. These discoveries represent a necessary transition. We are moving away from an incomplete model of the early universe and toward one that matches what we can actually see. This discovery shifts our perspective on the cosmos from a solved system into a landscape of profound unknowns. The universe is under no obligation to adhere to human logic or our expected timelines. The answers to these contradictions are contained within infrared signals that have traveled for 13 billion years to reach us. Our search into this backward timeline is an attempt to translate that ancient light into a new understanding of reality. The breakdown of our current models is not a sign of failure. It is evidence that the true story of how the universe began is finally being told.